So the traditional view that a computer is a device where you go and there's a CPU and you work at the terminal, that's pretty much gone. Nowadays, every device is practically a computer and provide programming interfaces. So any device can be programmed. So in the future, programming is considered to be a basic skill to acquire and not really confined to professional programmers. So yeah, so almost all electronic gadgets today have a smart component, and they're kind of everywhere. So there's no notion of what is a device that cannot do computing these days. Okay, now let's start with a basic objective. Why should I do this course? Now, you are the person to answer this question, depending on what kind of requirements. So if you're from a business analytics viewpoint, you may have to write code for a particular application that your company needs or something like that. So as I said, in the future, programming is expected to be a basic skill, just like doing arithmetic by hand was considered a basic skill even 70 years ago. Now, for that, you should have a basic understanding or a mental model of how computers work, even though not a precise, in great precise detail. You should be able to write own programs for custom purposes, right? And have a basic understanding of how computers can be used to automate repetitive tasks. One mantra that you can keep in mind is that if a task is repetitive, tedious, and involves a lot of manual labor, it can probably be automated. And one way of automating it would be to write a small script. And if you keep this in mind, that if I have a manual task that involves a lot of tedium and a lot of repetition, maybe there is a script that can do it. So in that sense, programming is expected to be a standard skill that everybody should have. Okay, so now a brief introduction to the process of programming. Programming is nothing mysterious. It is just a systematic way of explaining how to solve a problem. So you have a problem description, and normally you would think that from the problem description you go straight and solve it in code. So you pick a programming language and then write the code from scratch. This is usually not how things go. So how things would go is that you formulate a model of the problem. Often the problem description is given in a real world setting, and you may have to make things more precise, like what is the expected output, what kind of inputs are expected, what is the range of the input, what are the constraints, and so on, and how exactly do we need the output. So you need to construct a model of the problem, not exactly a mathematical model, but at least a more precise model for which you can write a program. Then you come up with a logical solution, and this is what is usually called an algorithm. For the purpose of this course, the algorithms will be very simple, they'll be straightforward. And then once you come up with a logical solution, you write the code. You pick a programming language that you are comfortable in, and then write the code in that. So this course will help you to, once you get a logical solution, how do you write the code in Python? Okay. Now, once you are more comfortable with programming, of course, there's no distinct phase. Expert programmers do often go straight from the problem description to the solution. But this is, even for expert programmers, there is a sense in which you should pause and ponder what is exactly to be done. And it always helps in clarifying the solution. Okay, so as I said, the first step would be to define and model the problem. Whenever you have a customer or somebody, and the customer could be yourself, I want to automate this task. This is often mentioned in a very vague language because customer requirements are not often precise, and it's up to the programmer to examine what is the problem and design it in such a way that the model is extremely precise and can be programmed and can be solved using a problem. Now, if the model is proper, which means it could either be too vague and therefore does not solve anything meaningful, or it could be over precise and it solves something, but it does not solve the actual problem. So, there's a balance to strike. So it should be precise enough and it should solve something close to a real world problem. So if you have a complicated system like, okay, for example, the Indian Railways, which handles a huge number of millions of passengers every day and reservations and so on. So uh, if you don't model it properly, like the expected demand at 10 o'clock in the morning, how many people will try to book trains and so on, you will get annoying error messages like service and unavailable, or you could have ridiculous error messages like your session has expired and this happened because you have double clicked on some option without mentioning what exactly uh, what the user did wrong or something like that. So if the modeling of the problem is wrong, then your program could be worse than having no solution at all. So uh, making the problem explicit is one of the important steps in programming. Right. And once you get a problem kind of solved and not modeled in real world, um, so you can now think of coming up with a logical step to solve this problem. So of course, in this course, modeling is not an important step, unlike in software engineering courses. Here, all problems will be precisely defined, the constraints will be given, and so on. And also some examples will be provided, like, okay, here is how the input will look like, and here is how the output should look like. And we'll also give an explanation of why the output is expected to be so. Okay, and this often does not happen in real life, and this is part of a programmer's job to make it so explicit that you can write code about it. And once you have come up with a logical attack on solving your problem, then you can decide that, okay, here is a finite and step-by-step procedure to solve my problem. The language itself is not important. Like I said, I mean, depending on the comfort level that the programmer has, they can decide, okay, I'm going to solve it in C, I can solve it in Python, I can solve it in Java, depending on whichever language that the programmer is comfortable with, or depending on which language the team is using. Okay, but the finite step-by-step procedure is what is more important. And this finite step-by-step procedure is called an algorithm. And you can usually visualize this using a flow chart. Traditional computer science courses have always started from flow charts, and go through the step-by-step solution and so on. We'll be slightly more loose. We'll just assume that any finite length, well-defined procedure is an algorithm, and we'll try to code that up. Okay, so but there should be some step-by-step procedure, whether it's a flowchart or not. There should be some finite step-by-step procedure that you have a rough idea of how to begin with, and then you can start the programming process. Okay, so in our real life, are there such programmatic step-by-step procedures? And the most famous such a procedure would be something like a cooking recipe. And people often say that you should not push an analogy beyond a certain limit, but the analogy of a recipe goes a long distance in understanding the concept of an algorithm. And we'll come back to this again and again, because many aspects of recipes are similar to what algorithms are. So how does a recipe look like? Okay, and this is from a website on cooking, and it says, how do you make a chocolate cake in a microwave? And so you start with a collection of ingredients, refined flour, baking powder, and so on. And then, so once you list the ingredients in appropriate amounts, then you say, okay, once I have the ingredients, how do I make the cake? How do I bake the cake? So you say, okay, there are 4 steps. In step 1, sieve the flour. So any person following the recipe will expect a few things to happen, right? Nothing which is described in the method. So during the method, you should not suddenly have an ingredient which is not listed in the original list. Okay, you should not suddenly say that I need cheese, and cheese is not listed as an original ingredient. People will get annoyed. Also, the reverse is true. You should not have a long list of ingredients and then have a method in which half of those ingredients are never used. So people expect a recipe to be a fairly tight description. Give me the ingredients, give me in what amounts you need them. And then once I have the ingredients, how do I follow a particular method where in 20 minutes I can bake a cake or something like that. Okay. And you will see that algorithms also follow a similar structure. You will list the variables. These are the variables after which I'll use during the computation. And then I'll say, here are the steps to solve the problem based on those variables. Okay, so this recipe has been taken from the web. Another famous example of algorithms in real life would be to, assemble uh, some make it yourself project or furniture or something that you bought. So you will, along with the disassembled pieces, it will come with an instruction sheet, and then following the instruction sheet, you can kind of assemble the furniture. So this is also an example of a real life algorithm. Okay, now for the final step, you have to convert this algorithm, which is basically a step-by-step procedure that you have written on paper or you have a rough idea of what to do. Now you have to convert it into a working code. For that, you should pick a programming language. And for this, you should understand which language you have to pick. And whichever language you pick, you should have a fair idea of what is called the syntax, which is the grammar of the language, and what we call the semantics, which is what exactly happens when you code in a certain way. How does the program work? Okay. And if at any phase, like if in the phase of making the problem precise, or if in the phase of creating the logical solution, or in the phase of translating the logical solution into code, if there is an error in any of these phases, the solution will be wrong. The program will be wrong. So this is often called garbage in, garbage out. If your model is wrong, or if your logical algorithm is wrong, and if you code it up precisely, because your logical algorithm is wrong, the program will also be wrong. Okay, so this is roughly the idea of the process of programming. And we have picked Python partly because by many measures, this is the most popular programming language of the modern era. There is a rich amount of libraries that you can use. So if you want to build a web server, if you want to build a data analytics engine framework, many libraries are already available. So it enables you to build on the work of others in a very time-bound manner. So Python is a very rich language. The other thing why Python became so popular is that it's a very simple language. It doesn't have too many syntactic constructs. The code once written looks very simple and readable. And this is why one of the reasons why many libraries were written in Python, and now it has become one of the most popular programming language. Okay, so now let's have maybe a quick round of introductions before we begin discussion of Python proper. Okay, so how do we do this?
I guess they can go probably,
That's,
we can call their names and they can unmute and just say a couple of words about themselves.
so maybe, okay. Manish, can you take a lead on this?
Yeah, sure. Yeah, Amy, I'm unmuting you. Can you say a few words about yourself? Hello?
Okay.
Hear from her. Danny?
Hi, yeah, I'm Danny. I go to the Ivy Business School, and I'm in the Masters of Business Analytics program.
Yeah.
So this is one of our courses. We're taking this course online.
Okay.
And yeah, I think I have a passion for analytics, and I'm hoping to learn Python.
Right.
Thank you. Bandish?
Hi, my name is Bandish, and I'm also a student at Ivy studying MSc in Business Analytics.
Okay. Maybe you can mention if you have a programming background or you're starting from scratch.
Yes, so I have learned C and Java in my high school.
Okay. Yeah. So, thanks.
Okay. Amy, can you try once again? She was having some problem with her microphone.
Okay.
Let's see. Okay, probably sometime later.
Yeah.
Okay. Elisa? Eva?
Oh.
Evan?
Are people online? Or?
No, they are online. I think they are trying this thing for the first time, I guess, on this class. You should try it out because it's a live classroom. So the idea of having live classroom is that you can ask questions. Otherwise, you can find many recorded courses. So you should be more interactive in this class. Harsh?
Hello?
Yes.
You can hear me?
Yeah.
Yes.
All right, perfect. Hi. My name is Harsh. I'm also in the business analytics course at Ivy Business School. I don't really have much of a programming background. I have done a little bit of Python on the side, but it didn't really stick with me, which is why I'm taking this course again to really familiarize myself with it. And yeah, I'm just really interested to learn more about Python because it's a very, very strong programming language, and I'm looking forward to learning about the tips and tricks to make myself better with it.
Okay, thanks.
Thank you. Ishani?
Hello?
Hi.
Yes.
Yeah. My name is Ishani and I'm a petroleum engineer. I just started my career as an associate business analyst and I don't have any programming background. So I will be starting from scratch.
Okay.
So yeah, that's why I've been taking this course. Thank you.
Thank you. Jackie? Jason?
Hi, my name is Yasser Aldada. I go to Ivy School I'm part of the business analytics program. I have no programming background. I only know SAS, but I know Python is much harder than TAPS. Thank you.
Jonathan? Oh, Jackie is there. Yeah, go ahead, Jackie. Jason? Jonathan?
Hey, can you hear me?
Yes.
Okay, so I'm Jonathan. I'm currently studying my MSc Business Analytics at IB as well. I have a background in programming, mostly MATLAB and like C++, but some like basic understanding of Python. So I'm just excited to learn a little bit more.
Thanks.
Okay. Kyle?
Hello.
Yes, we can hear you, Kyle. Okay, Mike.
Hey.
Hi.
I'm also a student from IB. And yeah, so like the others, I don't really have a programming background, but I know Python's really useful, so I'm really excited to learn this.
Okay, thank you.
Natalie?
Hello?
Yes.
So I am also one of the MSc students. I don't have much of a programming background, but I'm excited to learn Python.
Okay.
Olivia?
Hi, my name's Olivia. I'm also a student at Ivy in the MSc program. I don't have a background in programming, but I'm excited to learn Python because I feel like there's a lot of applications to it moving forward.
Okay, thanks.
Peter?
Hi, can you hear me?
Yes.
Perfect. I'm Peter. I'm also from Ivy Business School doing a master's in business analytics. I don't have a really big programming background, but I'm excited to learn Python.
Sumit?
Hi guys, this is Sumit. I am currently 15 years of experience in IT industry and currently working with a leader in phone industry. I did my MCA, so it's Master in Computer Applications way back in 2004. So I have been working in Hadoop applications since past 3 years now, and I want to move into the machine learning down the line. So that's why I'm just trying this course.
So it's Java, right? Your experience.
Sorry, I didn't get you.
Your experience is in Java.
No, I'm not experienced in Java. I'm experienced in Hadoop infrastructure services.
I see. Okay, thanks.
Yeah. I do develop some scripts in Shell, but for as far as Python goes, this is my first touch with it.
Okay, thank you.
Shiv? I think I don't see microphone in front of Shiv, so I don't think he has access to microphone.
Ooh.
So again, yeah, the last Shiv Khanna, I don't see he has a microphone right now. So again, I would encourage you to take it as seriously as you would take class, any course at Ivy. The other thing, this is the first class, but I would encourage you to keep your video on as well so that you are focused and engaged during the classroom. It's very easy on the online course if you're not seeing the other students and other students not seeing you to get diverted and start doing some other things in between. And you think that this is trivial and you'll follow it later, but it's better to keep focused. And every few minutes, we'll be asking questions. And from the next lecture onwards, we'll be having online, we'll have quizzes as well during our lectures. So please ask questions if you, at any point, if you think that you are not following the material, either you can put it on the group chat or you can interrupt, or we'll take pause every few minutes and check with you if you're following the material. Okay. All right. Over to Satya.
Hi. Let's continue. If you have any questions, so maybe every 3 or 4 slides, I'll pause a minute, for a moment. And then if you have any questions, please interrupt me at that point. Yeah, this class is meant to be interactive, and please feel free to make comments, or if you spot an error, please let me know. Okay, so we'll start with a few basic things in Python programming. So what's the cycle? How does Python programming look like as a procedure? So you write, or what is called edit code in an environment, which is called a programming environment, or an IDE, an integrated development environment. Then once you write the code, you just run the code, give it some input. And if the code ran okay and it gave the expected output, then you may decide that you're satisfied or something like that. If it didn't run, there definitely is an error in your code. If it ran but gave an unexpected output, then there's some error in your code, and you go back to editing the code. Okay. And if it ran okay, then you can decide that you're satisfied, or you may decide that I may need to give more inputs to see whether it runs in all these cases, all the cases that I'm interested in. And then once you're done and you have no more inputs to test on, you can say that, okay, I'm done with the code, right? So this loop, which is write and then run and seeing whether it is okay, that is how programming cycle in Python is going to look like. And it's a lot of times, programming is more or less a trial and error procedure. It is often the case that things may not run in the first go. And this is no reason to feel dejected and give up. You try to, focus by looking at each line, what could be the possible errors, and try to pinpoint what could be wrong with it until everything runs to your specifications. So during the course, maybe a few examples I'll walk you through. So I'll pick a problem and then write some code, and then we'll decide that, okay, this doesn't quite work. Now, how do you know what is wrong with it? So let's pinpoint what's wrong with the program, go line by line, and then try to fix and that procedure of finding out errors, fixing them so that the program runs more correctly. This is what a programming cycle is going to look like. So trial and error is part of the coding process. Okay, so you write that program in, or edit your program in an editor, and then run your program on an output. Now, Python is an interpreted language, so a few of you have experience in C and C++ and Java. There's another step involved in those languages, which is called the compilation step. Python does not have a compilation step. If we go back just a minute, as soon as you write the code, you can immediately run the code. There's no compilation step here. If the output is not correct, you try to correct the program until, and run it again to see whether it is now correct, and so on. Okay, so now for the development environment for Python during this course. Okay, so for this course, I'll follow an online programming environment called Trinket, which I'll share on the website. Already some quiz questions for the course have a Trinket embedded into it. So this is a web-based IDE, which means that you can run it on your browser. You don't need to install anything on your computer. And it consists of an editor and a console, which is where you see the output and you want to interact with the program and so on. So you edit your code in the editor, and then you run the code and see the output in a console. So the IDE looks like this, where inside on the left pane, you have the editor where you say that my code is print hello world. Okay, and we'll go through this process. Just I'll show a few screenshots, and then we'll go into a live editing session. Okay, once you have edited the program, on the top you can see this button called Run, and if you click it, then on the right.
Interrupt. Do you want to use your slides right now because it's not visible?
Oh, I didn't share it?
Yes.
Sorry.
Yeah, so you may want to go back to Trinket and show just quickly Trinket.
Okay, I don't know. Okay, just a minute. Oh, wait, there's something wrong with screen sharing. Let me just... Okay, is it visible now?
Yes.
Okay, so yeah, so as I was saying, the IDE that we'll use in the course is something called Trinket, which is it's an IDE development environment that runs inside a browser. So you don't need to install anything on your computer. And it has an editor and a console. It looks like this. We'll go into a live session soon, but just to see a few screenshots. So it says, on the left pane is the editor, and you type your code into the editor. It currently says just hello world and a print hello world. And then on top of the window, you can see a run button. And once you click on the run button, it will run your code. And the result of executing your program will be seen on the right pane. So it will just say, powered by Trinket. I mean, just below that, it says hello world, which is what I wanted to say, what I wanted the program to do. Okay, so that's the output. Now, there's another component called console. So if you click on the run button and the small down arrow on the button, you can see another option called a console. And again, it opens in the right button. And console is an interactive shell that you can type things in and you can see the output immediately. So this is, in addition to editing on the left pane, you can also say that, okay, I'll try to make some small code run in the console. So this is an interactive shell, and you can interact it by typing small pieces of code, like for example, type 1. So it shows some output corresponding to that and so on. So you can, in Python, you can either edit it on the left pane, or if you want to do some quick evaluation, you can do it by opting for the console and then typing it in. Okay. Okay, so let's, before we go further, let's just try a live session. So I'll go to this window. Which window is showing now? Is it the
trinket? Yes.
It's showing the trinket window. Okay, so yeah, I hope this is visible to everybody. So I'll just, so this is how the window looks like inside your browser. I'll add some instances of the trinket window that you can run directly off the ACADS website. But here is a file called main.py. And then I can type in some small code. So for example, hello. And there's a run button on top. And if I click on it, on the right pane, it shows the output, hello. So when you have a large amount of code to enter, you typically do it in Python in the editor pane. But you may often need just a small script just to try out something for the time being. And for that, you can opt for this thing called console. And you see the console has a prompt, which is this left arrow or right arrows. And there you can type some small expressions, let's say 3 plus 4, and it shows the result of an evaluation. Of course, you can type any Python line here in the shell, in the console, and it will show the output there, then and there. So there are two ways to run something in Python. One is to save it in a file, edit it here. So you can also say print 3 plus 4. And then just say run. So now there are two instructions in the file, which is print hello. So that's the first line of the output. And the second is print 3 plus 4. So it printed 7. So you can either do this or pick the console and then type whatever you want directly there. So it can execute small lines of Python code. And this is very convenient because if you want to try out something before you incorporate it into your code, you can quickly try it out in the console and then come back. Okay, so both of them are quite useful. So for the moment, I'll go back to the slides. Okay. So a Python program can communicate its result to the output using print statements. We have seen some examples like print hello, which we put within single quotes, or print 3 plus 4, which we directly gave it as a number, a numerical expression. And on the other hand, you may also need to take information from users. So for example, maybe you're building a reservation system and you want to take the name and the age of the traveler or the customer. The function that Python 3 uses, the latest version of Python uses to read an input is the function called input, and it takes the user's input and reads it into a string. We'll come to what string means in Python and so on. Okay. So the input function takes an argument, which is the message to be printed on the console. And then when the user types an input, it returns that as a string. Okay. So details on how the string works will be later. Okay, so let's just take a live example. Go back to Trinket. Okay, so for example, I can say input, and the message that is given to the user is please enter your name, your first name. Okay, and this will return a string. So when the user enters something, it will So it will return a string, and this can be used later in your program. Okay, so let's call it first name. First. Let's see what happens when we run it. Okay, so when you run it, it says please, hello, which was the first message to be printed, and then please enter your first name. I'll enter, let's say, Satya. Okay, so it took the user's input and stored it in this variable called first name, and the last sentence said, okay, print the value of the variable first name. So the value of the variable first name is whatever the user entered. Okay. Or I can make a slightly prettier print, prettier message like hello together with first name. Okay. So I'll say, sorry. Right. So you have a small interactive program which takes a user input, stores it in a variable called first name, and then prints a message hello followed by first name. So it has it's a small interactive program. So the lesson here is that print is something that is used to print some value in the program out to the console, and input is used for the reverse purpose. It is used to take an input from a user and store it in some variable. And that variable, you may use it for further needs in your program. So I'll stop at the moment. And do you have any questions?
You can unmute and ask a question, or you can also put it on the chat. Both ways are fine.
Okay, there's somebody with a message. No questions so far. Okay, so I'll continue. Okay, so we have seen a small program which takes a user input and then prints out some message based on the input. Okay, so if you say like, how old are you as an input, it will print that message. And you print 35, you enter 35. 35 is not taken as a number, it is rather taken as a string. So it will print you're 35 years old. So here's a small interactive program. So it will print you're 35 years old. Now, if you print, if you give a function called type, so age was the variable into which you stored the user input. The user input was 35, and you stored that. Okay, this. As well as currently. Okay, somebody has asked, do you want us following along and writing code in Trinket as well currently, or just follow what you're doing on the screen? So right now, for this lecture, just follow it because this is an introductory lecture. And we'll give assignments and small quizzes where you can try out things on Trinket. And later, in later lectures, we'll also have some programming assignments which you can code on Trinket and then submit. Okay, I hope that answers your question. Okay, so let's, coming back to the what we were discussing. So we have the user entered 35 and we stored it into a variable age. And using the function type of age, you can see what type age is. And contrary to what we expect age to be something like an integer because 35 is after all a number. And it will say that age is a string. This is because input takes whatever input that the user has entered and takes it into and stores it as a string. Okay. So for example, you can't say something like 35 plus 2 or something like that, because 35 is a string. Okay, so what we have seen so far is that programming is modeling, coming up with a logical solution, and then coding in a programming language of your choice. We have introduced Trinket, which is a web-based IDE. We have seen how to interact with Trinket. Either you can edit your code in the left pane and click the run button, or you can take the console and directly type your code into the console. Either way, you can interact with Trinket. And we have also seen how to print certain messages onto the output, as well as take some input from the user. So these are the basic things. Now let's look at a few elements of the Python language in more detail. So a Python program is a sequence of definitions and commands. Okay, we'll come to definitions in due course. Right now, everything that we have written, like print or input or type or anything of that sort, is a command. Okay, so commands manipulate objects, and objects are a precise concept we'll see in the course. And each object has a type. Okay, so a type is a set of values, and you can operate on these values. And so examples of types that we'll see in this course are integers, floating point numbers, which are certain kinds of real numbers. Similarly, strings. Okay, so when you say string is a type and integer is a type, integers support, let's say, operations of addition, multiplication, division, and so on. Whereas for the type called string, division is an operation that probably does not make any sense. So what kind of operations that a certain object supports will depend on its type. Okay, so these are the concepts that we will use in due course, and we'll define them properly in due course. Okay, right now we have seen only statements and variables. So using variables and types and things like that, you can build what are called expressions. And so we have been using a few types in the program so far, and you should be familiar with the notion of a type from school mathematics. So we normally see natural numbers, which take values 1, 2, 3, and so on. And then they support operations like addition, subtraction, multiplication, division, and comparison like greater than, less than, and so on. So these are operations that you can do on the type of natural numbers. You may also have seen complex numbers, which are written like 5 plus 3i, where 5 is the real part and 3 is the imaginary part, and so on. And complex numbers will support operations like addition, subtraction, multiplication, division, conjugation, which is not defined for natural numbers, but it's defined for complex numbers, and so on. So depending on which type your object is, it may support different operations. And you may remember from school mathematics that you cannot compare two complex numbers to see whether they are greater than or less than. You can compare two complex numbers to see whether they are equal to each other, but certain operations which natural numbers support will not be supported by complex numbers. And conjugation is an example where complex numbers support the operation, but natural numbers do not. Okay, so now let's look at how these are mathematical concepts that we've seen in school mathematics. How do they correspond to types in the Python programming language? There's the int type. So these are integers which have an upper bound and a lower bound. So small integers like 732 or negative integers like -5 are okay. But there is a maximum possible representable integer and a minimum possible representable integer. We'll see the exact bounds later. Similarly, real numbers are represented by what are called float. Okay, these will be numbers of the form, let's say 3.14, which is an approximation of pi that you may want to use in your program, or 2.0 or something like that. So floating point numbers are the machine representation of real numbers. Now, in addition to integer, suppose you may want to use very large integers in your program, which int does not support. So you may use this type called long, which support long integers with unlimited precision. In addition, one commonly used type is string. We have already used this when we said print hello world, or when we took the user as user input into the variable first name. The type of the user input would be taken as string. So one characteristic of strings in Python is that it will be included in single quotes. Okay. So it's customary to divide the types in Python into two types. One is scalar, which is indivisible kind of atomic types, which cannot be further decomposed. For example, integers, floating points, Boolean. Boolean would be something like true or false. And there's a type called none type, which has a single object, which is called none. We'll see its use later. Okay, so these are the types that we'll commonly encounter in the course, and these are scalar types. You cannot decompose them further. There are also non-scalar types, which have further internal structure. For example, strings. When you have a string, you can say what is its first character, what is the first character in the string, what is the last character in the string. Similarly, what is the length of the string, and so on. So non-scalar data types have internal structure, which often you can use in writing programs. Okay, so you can try this out in the Trinket on your own. So for example, if I have the number 500 and you say type of 500, it will say it's an int and so on. So if you type a decimal, a real number with a decimal point, and you say type of that number, it will say it's a float. Now, true with a capital T is of type bool, which stands for Boolean types. Boolean types have two values, but one is true and the other is false. And if you give it a string, like hello class within single quotes, then it will say that it's of type str, which is a string type in Python. Understanding types and how to handle errors in types is very crucial to programming in any modern programming language. Okay, so you have to get used to this fact if you're new to programming, that certain objects have certain types and only certain kinds of operations are allowed for those types. Okay, so here's a composite, slightly complicated object, type of 3 not equal to 2. 3 is an integer, 2 is an integer, and not equal to is a comparison. So since 3 is not equal to 2, it will return the value of this expression is true. And we have seen earlier that type of true is bool. Okay, so 3 not equal to 2 evaluates to true, and type of true is bool. And that's why it returned a bool. Okay. So now we'll come to something called, often we have seen in this example that the user input something and we may take it as a string, or there may be occasions where we need to treat it as a different data type. Okay. So for this, what we need to do is you can take a value of a certain type and convert it into a different type. Before we go into the slide, let's see a practical, live example. Okay. And then I'll take some questions. Okay, so I'll take the Trinket window. I hope it is visible now. Okay.
Just a comment, Satya.
Yeah.
For this, from the next lectures, probably you can have a trinket window from the ACAD sites open. And so you can, while Satya is explaining something, you can try it at the time of lecture itself.
Right. So I guess it won't conflict, right? Each person has his own instance.
Correct. Yeah.
So yeah, sorry. So this time I didn't embed it in the ACAD's website. There is a quiz question in which there's a trinket embedded into it, but the live session I didn't embed it. Okay. So I'll just clear out this code and look at the code and type in the code that was used in the slides. So for example, I can say, okay, so this prompts the user to input their age. And if I say, so, okay, so let's say that I enter my age. It will say that the type is string. Okay, so now I may need to do something further down in the code. So if say something like if age is greater than 60, so we'll come to these constructs later. But let's say that I want to do a comparison. You are eligible for some privileges. Okay, right now let's say that's so it just takes a comparison. So the user enters an age, and depending on the age, you are eligible to have certain more privileges available to you. If I try to run this code, you will get something called a type error. Okay, so let's try to do that. Okay, so this was completely nonsense, right? I mean, I entered a number like 35, and what I got was that something, okay, so you're eligible for senior citizen privileges. So this is happening due to type error, where the age which is supposed to be treated as an integer is being treated as a string, and something strange is happening in your output. Okay, so you're not meant to see this message, right? So one thing I may need to do is to change the type of age from a string to an integer. So I'll say that let me make it less confusing. So I'll call this value. Okay. Okay, so this code, what it's supposed to do is that it takes a user input, stores it in a variable called value, and then whatever value is, we have seen it earlier that value will be a string, convert it into an integer. Okay, and then I'll print the type of age, and now hopefully it should say that it's an integer. Okay, so that worked. So just for comparison, if I type the if I print the value type, yeah, so this should be a string and the age should be a number. Yeah, so you can examine in the output that the first line says that value is of type string, and the third line says that integer age is of type integer. Okay, and maybe at this point the earlier thing should work. If age greater than 60, so let's say something. It didn't print the senior output, which is expected. Let's try to run it again. And if I say that my age is 78, and now the comparison worked right. So earlier you saw that it was behaving in an absurd manner. I entered a small number and it said that I'm a senior citizen. Right now I converted the input value into an integer. And once that was done, now things started behaving in a more reasonable manner. So often you may have to convert an object of a given type, values of type string, and you have to convert it to an integer. So this operation, which is to say int of value, this is what is called a type conversion operator. You take an object of a certain type and convert it into a different type. And this is often needed in programming languages in all kinds of settings. Okay, so let's go back to the slides. Okay, at this point, are there any questions? This is quite unnatural in real world settings. Okay, just a minute, there's a message. What is the type of value string in the first? Why is the type of value string in the first place? Because input function always returns a string. Okay, it would be nice to have an intelligent input function which depending on the value that the user input will decide that, okay, this looks like a string, or this looks like a number, or this looks like a float. But the input function that Python gives is pretty plain. So it takes whatever the user gives and just returns it as a string. Okay, so you will have to do the extra work. But it's possible that some more intelligent language might have this operation, but Python doesn't have it. Okay, I hope that answers. Thanks. So okay, let's go back to So we have seen an example of the type conversion, and now. So this is used to convert some value of a particular type to another type. And we are used to converting integers to floating points in normal maths. So for example, we don't distinguish between the integer 3 and the floating value 3.0 when a real number is expected. Now, the reverse process is also very common. We may get a floating point number like 3.6, and it's often truncated to as 3. In financial settings, for example, it's typical to work with 2 decimal places after the decimal, two values after the decimal point. So that can be seen as some kind of a rounding. So when you round or truncate a floating point number to an integer, this can be seen as a type conversion that we do in normal settings in mathematics. So how do you convert from one type to another? Suppose you have a string and you want to convert it into an integer. You say int of that variable. Okay, so the type names themselves are used as type converter functions. We've seen this. So int of 2.5. 2.5 is a floating point number. And when you say int of 2.5, it will return a 2. Similarly, int of 2.3 will be a 2. Int of 3.9 will be a 3. So please watch out that this conversion from float to integer is not rounding. It is truncation. If it were rounding, you would expect that int of 3.9 would be 4. But it returns a 3. So basically it truncates to the integer part. Now, if you can also do the reverse. So if you give an integer and say float of 3, it converts the integer into a float. Similarly, int of 73 within quotes. So 73 within quotes is a string. So it takes the string and returns the number that it represents. So this is 73. This is similar to the program that we just wrote, where we took an age as a string and then converted into an integer. We saw that if we didn't do that, then the program would behave in very strange fashion. Okay. Now you can try out certain erroneous conversions. So if you have a string like ACADS, okay, and try to convert it into an integer, it really can't do it in any meaningful way. You can try this out in the Trinket session, and you will see an error message. Okay. So it says invalid literal for int with base 10. So it says that the ACAD string cannot reasonably be interpreted as a base 10 integer. Okay, which is reasonable. 73 could be done because it looks like a number, whereas ACADS is not a number and therefore cannot be reasonably converted into a string, into an integer. So you will get some error message if the type conversion cannot be done. Okay, so try out a few of these. So we have seen this. Okay, input always returns a string, and then in order to convert it into an integer, so if you directly do age plus 5, it will give an error message. But if you say in 5 years your age will be int of age plus 5, what it does is it converts age, which was a string, into an integer, which is now the number 35, and adds 5 to it. Okay. In 5 years your age will be 40.
So Satya, I have one poll for the students, just 1 second, related to what you covered. Can you see this poll? It's based on type.
Yeah. Okay. So is it live? So there.
Yeah, we see 6 students have answered, 7 now.
Okay.
So this is something which Satya specifically covered in the last slide. So pay attention to what you asked. Okay, it seems a lot of students have answered. So I am ending it. 5 more seconds if anyone else want to answer. Okay. So.
Okay.
Can you see the results?
Right. Yeah, so I guess most people have got it.
So most, yeah. So one thing was that the type of here it was a bit tricky because here, remember, note that 3.0 is, it's not 3.0. It
Actually,
was
it's within quotes.
It's within quotes. So it was a string. So it was a trick question.
So yeah, so this is, please pay attention to the single quotes. Yeah.
So you can go back to the previous slide.
If you just go back to the.
This int 73, it was similar to that.
Yeah. So the int of 73, right? I mean, so the string 73 is within quotes. So it's a string. Okay, so do you want to relaunch? No.
No. Okay.
Yeah, thanks. Yeah, okay. Okay, so let's go ahead with some operators. We have already seen it in the previous slide. You said int of age plus 5. So the common arithmetic operators that are supported by the integer type are plus, minus, star, which stands for multiplication. This division has 2 modes. One is this double slash and the other is the single slash. and I'll mention that in a minute. And then percentage stands for the modulo operator, which is the remainder after division. Double star is the exponentiation. Just a minute. Okay, there's a question, I guess. Yep. Thanks. Okay. Yeah. So the double slash, and so I think the most common thing is to have, you know, if you have an integer 3 and another integer 4, what is the result of division of 3 by 4? Okay, so you will expect something like 0.75, but in other cases you may want the result of the integer division, so you want only the quotient. So the quotient is going to be 0 in this case. So you want to distinguish between cases where something like 3 by 4 is supposed to return me the floating result, which is 0.75, or results where I just need the quotient, which is always an integer. So if I want the quotient operation, then I'll use a double slash. If I want the proper division, which gives me a floating point result, then I'll use the single slash. Okay, so please note this. And there is a quiz question in which I've used the double slash operator. Try the same, so try the code with the single slash operator as well. Both of them are meaningful in that particular question. The comparison operators can be like equal to, not equal to, and so on. Greater than, less than. So greater than or not, greater than or equal to is written in the following way. You have a greater than symbol and then an equal to. Less than or equal to, you have the less than or less than symbol first and then the equal to. Okay. If you're completely new to programming, the double equals is a huge mistake that all programmers make. In the next line, you can see something called the assignment operator. That is the single equal to sign, and it's a big mistake, and based on the behavior of your program, it's very hard to detect this. That often people use a single equal to when they mean a double equal to. Okay, so we'll have a few practice questions so that you get used to these differences. Okay. The other operators are slightly more tricky. They are operators available in Python, but I'll try to avoid using them because their semantics, what they mean is slightly tricky to understand. Okay, but for the sake of listing, they're present there. You also have logical operators like and, or, and not. So true and false will evaluate to false. True or false will evaluate to true. Not of true will evaluate to false, and so on. So these are logical operators. And then there are bitwise operators where you can operate on 2-bit sequences. And so these are advanced topics that we'll probably not use in the course because the integer types will use integer types, integer operations, and comparison operations on the integers. But for the sake of listing, these will be given and you can use it in your code. Okay. In addition, you have membership operators like in and not in, and we will use them extensively as the course. So identity and so on. So these are membership and identity will be used when we cover more sophisticated data structures. And in the final lectures, these functions, these operators will be used quite extensively. Okay. We will not cover bitwise operators because that's slightly beyond the scope of this course. Now, to end this session, I'll briefly mention the notion of variables. We have already used variables in the live code that we saw on Trinket. We have used first name, we have used age, and so on. These are variables. A variable is just a name associated with an object. And we have used that first name equal to input some method. So that equal to was the assignment operator. And assignment operator is used to say that this variable is associated with this value. Okay, so when you have an expression like m equal to 64, okay, that semicolon is probably not there. But okay, if you just look at m equal to 64, 64 is the number, it's an int that you associate with the variable m. Okay, so you can imagine that your computer has a memory, and somewhere in your memory, you store the number 64, and that value 64 will be associated with the name m inside your program. Okay, similarly, you can say C equal to the string ACADS, F equal to a floating point number 3.1416, and so on. A variable can change to a different value later in your code. So suppose your code is of the following nature: m equal to 64, C equal to within quotes ACADS, F equal to 3.1416. Later in your code, you may say F equal to 2.7183. Okay, some approximation of E. So at some point in your code, F may point to the value 3.1416. Later, at some other point in your code, it may refer to a different value. So variables can change their association to values later in the code. Okay, now what kind of names are valid? So these names are called identifiers, and the names are given to various concepts in the Python language: variables, functions, classes, and so on. Names consists of letters, digits, and one particular special symbol, which is the underscore symbol. This is not the hyphen, this is the underscore symbol. As we saw in the code, we have used two variables so far in our code that we have seen in the lecture. One was age. It was just A, the small letter A, G, E. Okay. Earlier we had seen another variable which was first name, where it was first underscore name. So both these are valid names. So here are some examples of valid variable names: count, lab5, and so on. You cannot, one thing that's ruled out is your variable cannot start with a number. So it always must start with either a letter or the underscore. So phi-lab is not a valid variable. And you can mix capital letters and small letters. So here are some invalid variable names. Phi-j, because it starts with a letter. Min profit is an invalid name because there's a space in between. Lab.7 is invalid because dot is not a valid character. The most important thing to note is that Python is case sensitive. So capital A ACADS is different from small a ACADS, is different from all caps ACADS. These are different names. And so the variable names are case sensitive, and this is something to watch out for. Certain names are not allowed to be used because they're already used by the standard Python libraries and the language. They have special meaning. These are called reserved. So we have seen true with capital T, false with capital F, class, in, is. So these are all operators. We have already seen them. So these words are already used by the Python language in some form or the other. And therefore, they are not available to us as names. So these are things to watch out for. You should not name a variable false and say false equal to something. You may get an error. So there is a cheat sheet that we have provided along with the course. And in that cheat sheet, you can look at the reserved keywords, what are the operators available, and so on. Okay. So you should always choose meaningful names in your code. So if you just use a variable like C, it's not easy to understand what C stands for. Whereas if you give a more descriptive name like count, okay, you know that it's meant to store the count of something. And it should be easily readable and understandable. So count is preferable to C underscore O underscore and so on. we would recommend that you have full words, complete words, and abbreviate only when it's clear what it means. So max is all right because, but in certain cases, abbreviation actually confuses things. So we recommend that you give full words. Okay. And avoid unnecessarily long names. So as in everything, there is a balance. Okay. So counter is preferable to a loop counter. Okay. So these are things that where, follow your own judgment. Okay. So I'll stop this session with just a discussion of the assignment statement. So if you say a variable equal to expression, this is an assignment statement in Python. We have seen examples where we said first name equal to something, age equal to something, and so on. So computes the expression value on the right-hand side and then stores it on the left-hand side. So this is what the variable equal to expression is supposed to do. Okay, so here are some examples: x equal to 10, disk2 equal to b times b minus 4 times a times c. So all these are expressions. And so you have expressions on the right hand side and variables on the left hand side. You cannot have it the other way around. You cannot have expressions on the left side and variables on the right side. That doesn't work. Okay, so the expression is first evaluated and then it is stored in the right side. Okay, so I think we are nearly out of time and out of the slides. So there are some quizzes that we have posted on the website. Please try them out. They're not extremely involved because this is just the first session. In case you have any difficulties, please let us know by emailing. My email has been given, satya@acads.org. And if you have any difficulty or you can't figure out something, please let us know. One thing we have to decide is the tutorial time, right? The office hours.
Satya, I'm going to launch something on poll and we'll get this information.
So I'll stop sharing.
That's fine. You can keep this slide. That's fine.
Okay.
I was going to mention that since this is an introductory course, the grading will be based on quizzes. So the quizzes are graded. So make sure that you submit your quizzes before the next class. Quizzes are due before the next class, and that's how we'll follow. There will be programming assignments that's for your practice. Satya will be giving all along. Also, I think we'll just launch a couple of polls to get some feedback.
Okay.
And then we'll tailor this course based on your feedback and to see that it's most useful to you. And give your honest feedback. If you didn't like something, that's fine. We can learn. We all can learn, and we can make changes here.
Yeah, please be frank because this is the right point to correct. If you feel that the pace is too slow, the pace is too fast, whatever.
Yeah. Yeah, and for the students who have some prior knowledge of other programming languages like Java and C++, we will be posting some challenging problems as well on our site, which will be in Python. So you can learn the Python syntax and try out those problems. That will cover different aspects like writing, coming up with an algorithm, modeling, and then writing the code and testing your code as Satya was mentioning, and then we can discuss those problems during office hours. But since majority of the class is they don't have programming experience, and since this is a introductory course, so we will stick with a slow pace and cover all the basic materials, assuming that you have no prior experience. So just I want to set the expectation right here. So you may find few things which are very basic, but we have to cover in this course. Okay. This was one.
Okay. So I guess nobody said that it was difficult to follow, so that's good.
Yeah.
Yeah. So, like I said, some of you may find this very elementary because this is meant to be elementary. It's supposed to take you from zero programming experience to a level where you can confidently write at least small programs. And and for people who are familiar with programming in other languages, hopefully you can compare and contrast with the languages that you already know. So one difference we've seen already is that Python has no compiler. You directly write code and run it. So if you already know some languages, please compare with your previous experience as well.
Okay, I'm gonna end this poll in another 5 seconds.
Okay.
Some mixed response there.
Okay, so I will. I'm willing to hold an office hour. Only thing is to decide when is it.
In the chat, can you suggest some times which will work out for you? Let's say like morning hours, evening hours, whatever it is, and we'll see based on
this time should work on all weekdays.
Okay.
Maybe 6 to 7 Indian time. So you converted it to, I think it should be 8:30 to 9:30.
Yeah, so that will be 8:30 a.m. So probably because we are having this class on Wednesday, so we give a couple of days break. So probably Friday or Monday.
Yeah.
Maybe.
Sure, that works. So Friday works better.
Friday, so probably Friday, 8:30 a.m. Let's keep it that way.
Yeah. Oh,
okay, so
somebody says please don't make it Friday. So Monday is fine with me as well.
Okay, Monday, because the quiz will be due on the next day, Tuesday. So probably they will have a weekend to try quizzes, and then Monday, 8:30 a.m. should be fine.
Yeah.
Okay.
Okay.
All right. Thank you very much, everyone. Thank you, Satya.
Yeah. Yeah.
Thank you, guys.
Thank you.
Is it for me?
No, I'm checking with Olivia mentioned that she has, a lot of them have class on Monday, 8 to 11.
Okay.
Okay,
So,
I know they have class on Thursdays for sure.
Okay.
But then there are some students from this class is taking the other data analysis class as well. So I think Tuesday, if we don't hear otherwise, we'll keep it on Tuesday. And we'll send an email out with the information.
Yeah.
Tuesday.
Okay.
Okay. All right. Thank you.
So any feedback from your side?
No, I think it's pretty good. Excellent.
Okay. I was initially a bit shaky because this, the interface, is a bit confusing.
Yeah.
I think something froze at my end, which is why the slide sharing did not work.
Okay.
But, right.
Okay, so we will end this session, Satya. Okay, and I'll talk to you later.
Okay. Thanks a lot.
Thank you. Thank you very much.
Good.